Hi everyone, welcome to my YouTube channel Networking Made Easy by T S Srinivas. So this episode supposed to be the last episode in the communication basic series. Okay. Yet, even though this is the last episode, it's a very important lecture because this is going to be the main foundation for the advanced network actually. So the basic concept of networking actually started with this particular very concept. So the topic is the circuit switching and the packet switching. Okay. So basically what is actually the switching concept? See, so far whatever we have learned is the transmission part and the receiver part. So basically in the communication there are the three things which is involved: the transmitter, receiver and the medium. Okay. So after learning thoroughly about what are the different mediums available, what is the role of a medium actually. Okay. So by this time you might have understood the main concept of the medium is nothing but to carry the information from the source to the destination without any error. So that's what we have seen. So what is a resource in the medium is nothing but the bandwidth. So by this time you should have the sound knowledge about the concept called the bandwidth. Okay. So now how to make best use of this particular resource. Okay. So you will understand what is the importance of this particular resource called bandwidth. Okay. So now you see basically the original concept in the switching in the communication is the circuit switching. So what we understand from the circuit switching is, see, basically it's a dedicated communication path. See, what exactly it means is, see, whenever we make a voice call, okay, no sooner you lift the telephone, it doesn't mean that it connects to the destination and you start speaking. Okay, what actually the thing is involved is you make a call. So in the process, what exactly is happening is, see, in this particular picture, okay, this is the end office where actually your local telephone is connected. Okay, so there are intermittent offices like long distance office, likewise it gets connected. Okay, for a simple understanding you just see. So initially you just see these are all the terminations at one side. So one connection is connected at one particular point. Okay, this particular line which is drawn here, it is not always permanent. Okay, so actually this is happening in the process of a call setting up phase. Okay, so what is happening is whenever you are making a call, so each office allots certain resource, its resource, that is nothing but the connecting resource. Okay, so now this is another link connected to the next office. So link means what? It's a medium. It is having a large bandwidth. So some part of the bandwidth is allotted for this particular connection. So this is how it is connecting to the next offices and finally it is reaching to the end office and it is giving a ring to this particular number. Okay, so no sooner this user lifts the phone, so this is connected. Okay, so now it is end to end, it is connected. Now the users are able to communicate fine. Okay, now actually see, once it is connected, these all equipments which is coming onto the path doesn't participate in the information part. It doesn't know what actually the information is being transferred. Okay, so whether it is transferred, not transferred, it is not its botheration. Okay, so what exactly it means is, see, that's what the dedicated communication path is being established before the information is being transmitted. That's what, before any signals can be transmitted, an end-to-end circuit must be established. See, once the connection is being established, then the information transfer takes place. Okay. So now see, another thing is the channel capacity is dedicated for the duration of the connection even if the no data are being transferred. See what exactly means is channel capacity is nothing but the bandwidth, isn't it? The bandwidth is allotted for the whole duration of getting connected. Okay, so whether you speak or not, it makes no difference. Okay, so if it is idle also, this particular resource is allotted for this particular connection. So basically, in the circuit switching, what actually the problem is, the connection, whatever the path is being established, is dedicated for this particular connection. The user, one user, this particular resource cannot be used by any other user. Okay, so now you just understand this is a very big what is the disadvantage in the concept called circuit switching. Okay, so you will understand better when we go furthermore into the discussion. Okay, so once the circuit is established, the network is effectively transparent to the users. So this is the best part of it. Okay, what is the best part of it? Once connection is connected means that's it. That resources is used for the user, means it is as good as it is directly connected and you can comfortably speak. Okay, so that is a fantastic part actually as far as the circuit switching is concerned. Okay, so now it is well suited. Now see, now here it comes. See, basically this particular concept, see, originally the communication means it was voice communication only. Okay, so that's the reason this particular circuit switching was working very effectively for this particular voice communication. Okay, so it is well suited. It is well suited to the analog transmission of voice signals. Okay, you just see, you made a call, you are connected, you are speaking, and see, you know, see, we are the individuals, we have designed this particular network, we know how to make good use of it. See, when you are speaking, not an issue. Till the time you are speaking, once the conversation is over, you disconnect the call, okay. The resource is released. That's fine. So that's a very efficient because we are not much bothered about it. Okay. But coming to this point, in a typical user host data connection, okay, so much of the time is idle. See, now the question comes, the data communication. Okay, data communication in the sense, so see, that's what the simple word is the internet. When you want to get connected through the computers, whatnot, the data is being transferred from one end to the other end. So in this particular process, see, in a simple example, when you are using internet itself, you say, okay, so whenever you are getting connected to the server, you are getting some information, that particular server, to your machine, and you are using it. Okay, you just understand in this particular, see, whenever you are using internet, okay, you are connected to the server, you want some information, that information is coming from the server to your machine, you are using it, fine. So when you are watching, you are reading, you are browsing, whatever it is, okay, so in between what could be happening? The connection is idle, no data transfer takes place. Okay, you just see the connection is being established and no data is being transferred from the source to destination or either way. So what exactly is the big loss? So here comes the wastage of the resource. Okay, so that's why this particular very concept called circuit switching is not at all suitable for the data communication. Why? Because see, whenever you want to send, large data is being transferred. It happens suddenly, suddenly a huge data is being transferred from the source to the destination, and most of the times it is idle. For this kind of things, see, even in this particular circuit switching, another drawback is it's a fixed speed. When the connection is being established, okay, it's a fixed speed you are going to achieve. See, if you say in our old discussion, like, time division multiplexing, okay, in the PCM pulse code modulation, time division multiplexing, what actually is happening? You see, say from this particular place to this place or wherever it is, up to end to end, you will be given one time slot. Okay, so that time slot supports around 56 kbps to 64 kbps, isn't it, theoretically? So that's why in another case, say as we have discussed in the dial-up internet connection, you can get only the fixed speed. Okay, so that is another big drawback. Even though you have a lot of resource available, you cannot expand your bandwidth. It's not flexible. So now this is the biggest drawback in the circuit switching, that you cannot go for data communication at all. Okay, so that's the reason we are moving to another concept called packet switching. Packet switching. So now this particular word called packet is very popular, isn't it? So when I am told this is the foundation for the very basic for the data communication part, is nothing but the packet switching concept. Okay, so now in this particular packet switching, what actually is happening is, so with the packet switching, a station transmits data in small blocks of packets called packets. See, generally now when we consider, now you'll forget about the voice communication presently. So whenever you are having a data communication, means large data is being transferred from host to the destination. Okay, so that time this particular large data, it is not being sent in one block. So what actually is happening is, this large data is broken into small pieces. Okay, now you just see, now very interesting part is, whenever the large data is broken into the pieces, now this particular thing, what happens? It has to go to the destination. Pieces are going into the destination. So one very important concept comes into the picture is nothing but the routing. Okay, now why? Because see, each packet you see here, each packet contains some portion of user data plus control information. It's very important. See, each packet contains some portion of user data. Okay, actually the user is interested in the actual data, but there is something added to this particular data with the control information. What could be the control information? Simple logic. Okay, so what is that particular logic? So it has to, that what control information should be there is that, see, it is the source address and the destination address, where it has to go. If you are writing something on that, see, I am so and so, it has to go into, it has to reach to so and so. Okay, this information you are putting, in addition to that some data is there. So when it is traveling onto the path, who is going to read? Okay, so definitely there are different nodes coming into the picture. So this node should have the intelligence to understand who is this particular source and who is this particular destination. And it has to have the knowledge how to route this particular to the destination. You should know, that node should have the knowledge where this particular destination is there. So that is the concept of the routing. Okay, now see what actually has happened. See, this particular problem was not there as far as the circuit switching is concerned. Why? Because you are end to end, you are connected, that's it. Now in between, see, once the node is doing this particular job of getting connected to the end to end, afterwards its job is over, it's said, there is no headache as such. The end to end user can transfer any amount of data just like that. Okay, the nodes doesn't bother into the user information. But here, what actually happened, this particular large data you are broken into the pieces, which we call it as the packets. So definitely in between nodes should come into the picture. So it's responsible for routing, okay, perfectly to the destination. Okay, so this is the very concept of the packet switching. Okay, by this, what actually we have achieved by doing this? So you just see here in this picture, I will be talking about this rest of the parts. You see this A, B, C, they are the end users. Okay, this 1, 2, 3, 4, 5, they are the different nodes coming in between in the network. Okay, Now you just see what actually is the resource. See, what is the resource between 1 to 2 and 1 to 4 or 2 to 4, whatever it is. This particular line, we call it as a link, is nothing but the medium. Medium resource is the bandwidth. Okay, now here, what it is in the packet switching, the connection is not being established in advance. It means what? There is no dedicated path for end-to-end user. It means no resource is allotted to any particular user. Okay, so it is choice of the node. See, in the node, so many users' data is coming at one particular place. So here comes the concept called buffer. So if the data is coming, different packets are coming from different users, it is landing at one particular node. What is it is doing? It knows it is keeping in the buffers. First come first. Okay, it is seeing, okay, this person, destination, so it will allot the resource to that particular person. Okay, so see, that's how it is. The whole resource is used very efficiently. Okay, so the resource of bandwidth is not allotted in advance. Okay, so now that's what the very big drawback of circuit switching is avoided in the packet switching. Why? Because you see, you no need to bother now. You see, large amount of information has to be transferred. So that particular time the information is being transferred, and once it has reached the destination, it's over, it's okay, fine. So no bandwidth is allotted permanently to the users. So the whole bandwidth is available with the network. The network is deciding at what time which user data has to be used by the link. So that is the very big advantage of the concept called packet switching. Okay. So going further here, now here you see, once you understood what is a packet, okay, what actually the packet contains, the user data and the control information. Okay, now here again comes the packet switching network adopts two approaches. Okay, two approaches. One is datagram approach and other one is the virtual circuit approach. Okay, so the datagram approach, you just see the datagram approach, again here we call it as a connectionless, and the virtual circuit we call it as connection oriented. Okay, now just don't confuse with the circuit switching concept. Okay, so now let us first learn about what is actually virtual circuit concept. Okay, now you see here, this I have written here as VC number 1. So whenever the virtual circuit is told, actually what actually is happening is, say for example, you want to send some data from A node to the A user to the B user. Okay, say this is the source and this is the destination. Okay, so in that case, virtual circuit 1. So in this also there is a small concept called call setup. Okay, it is unlike the circuit switching concept. What actually is happening is, what all the packets which are being sent to B user, so before sending the actual information, a path is being set up. A path is being set up means it's an understanding. It doesn't mean that you have been allotted with a resource. This is a very big difference between the circuit switching and the packet switching. Here in the virtual circuit I'm talking about. So whatever the packets is there, so what is doing is, there is a small phase which is involved, that is a call setup. So it is allotting one's virtual circuit number. So these all nodes, see for example, all the packets from A to B has to travel node 1, 2, 3. So now all these 3 nodes have an understanding. Okay, any packet coming with the virtual circuit number 1, it has to follow this path, that's it. So all the packets meant for B through virtual circuit 1 will be passing through this. Okay, so what is the advantage of this is, every time you no need to give the complete information of source and destination. Okay, just by looking at the circuit number, okay, the nodes will understand it has to be sent through this node, that's it. Okay, but it doesn't mean that the resource is allotted to the this particular user. Why? Because all the packets which is landing on any particular node, again the same process. It goes into the buffer, then the node will decide when this particular packet has to be sent to the next node, depending upon the rest of the traffic. Okay, so this very difference you should clearly understand between the circuit switching and the packet switching, especially the virtual circuit. Okay. So similarly, if you want to send data between A to C, another virtual circuit is being set up like this. This dotted lines showing the virtual circuit with the number 2. Okay. So if any, if any packet coming with the virtual circuit number 2, so this node will send to 4. 1, it will send to 2. Okay. From 4, it has gone to 3. Now 3, definitely see, it is having a packets coming with virtual circuit number 1 and 2. 1 means it will send to B, 2 means it will be sending to the node 6. So that's what. So it is a understanding. This is being done in the process called setup. Okay. So this is an additional requirement in the case of a virtual circuit. So we call this particular thing as a connection oriented. Whereas in the datagram, each packet is treated as a independent packet. There is no link between packet to packet. So in every packet you have to mention the source address and the destination address. So each node will not have, it doesn't bother about this packet. It will treat this particular packet as a new packet, independent packet. It looks as if it is coming first time. So if you understand better, you just see from node 1, the packets are being sent to, see, from A, it is being sent to B. So naturally, it is showing the destination address is B. Okay. So you find 2 packets are moving from node 1 to node 2. That is, B1 and B2 has moved to 2. And when the third packet has come, so it could be the reason, like because the traffic is more, the congestion is there. So if this particular path is clear, it will be sending to this way. Okay. So that is the concept called the routing. Okay. So once it is coming to this 4, so the 4 knows that it has to be sent to 3. Okay. It can send either, it can send to 2 or 5. Its choice is its. Okay. So it may be sending to 3. Okay. Similarly, you see when 2 packets have come to 2, see one packet has gone this side and other again B1 has come to this side. So naturally, when the packets in the datagram approach, you find they are finding different paths. Okay. Ultimately, it is reaching to the destination B. Okay. So now you find that packets could not be in sequence. Okay. So the end user the application knows how to make use of this particular packets. Okay. So that's the difference. Fine. Because certain applications, okay, when we start networking basics, you will understand certain applications use the virtual circuit approach, certain applications use datagram approach. Okay, if the information is very small, generally those applications will be using the datagram approach. Okay, so these things will be very much clear when we talk about the networking basics in detail. Okay, so once you understood what is a virtual circuit approach and the datagram approach, okay. So another point, very important point, is there is a significant relationship between the packet size and the transmission time. Okay, so we'll be studying in detail, but you just understand the large data is there. You are making packets. Okay, when you make a packet, so what should be the size? See, generally, by looking into all the means the transmission parameters and all other things, you will be finding that 1500 bytes could be a ideal packet size. Okay, you should understand. Now you just see there is whenever in the process there are two types of delays. Generally, see, when you find there is a propagation delay, isn't it? See, this is a transmission time taking from one node to the other. Okay, some time it will take, and similarly, there is a propagation delay in each node, isn't it? So, see, that's what these are certain delays which is taking place in this particular process. So now, generally, you see what is the importance of this particular relation between the packet size and the transmission time. You see, if suppose, for example, take this example, this when you are sending, say, 3 packets from node 1 to node 2. Okay, if the packet size is too large, what happens is this packet will land into this node and it is stored into the buffer. Okay, it cannot take action until unless the whole data is reaching to that particular buffer. Okay, if the packet size is big, whole thing is coming and landing into the buffer first, then it is looking at the destination address, and then it is start sending to the next node. You imagine the packet size is small. Okay, so what happens? So no sooner the packet is reached, before the next packet arrives, this node will take action sending that particular packet to the next node, isn't it? So that is what is a understanding. That's what. So if you want to make best use of this particular thing, the packet size has to be restricted. If it is too large, there is a problem. Problem in the sense there is a more delay takes place. Okay. So this is, as per me, this is a very important lecture as far as the circuit switching and the packet switching is concerned. So now see why actually you are moving into the packet switching. The whole internet is based on the packet switching. Okay, so initially the circuit switching we were using only for the, means it was best suitable for the voice communication. There was no doubt in it. See, in fact, the circuit switching is a fantastic part. Why, as far as the user is concerned. Okay, see, if you want to have a very small understanding, very simple example. See, whenever you are traveling in a city, okay, on your vehicle, suddenly you find a VIP is coming, passing by. Okay, suddenly what happens? Whole traffic is being stopped. The main road is being used by the VIP. Okay, it means the whole resource is used by the single user. Who is benefited here? The user is benefited, he is comfortable, he is very happy. But what is the problem? The rest of the traffic is having a trouble, isn't it? There is a delay. Even the management is also a difficult thing, isn't it? So that's why the network, so the resource management is very important, because nowadays everybody is looking for the bandwidth. You are connected and you are not using the bandwidth, so resource is getting wastage. So that's what generally happens in the circuit switching. Okay, so it was, see, once upon a time it was very good. It was utilized very nicely for the voice communication. Nowadays, even voice also being put onto the packet switching. So that's the reason the VoIP concept, voice over internet protocol, VoIP. So that already has taken place and things are working fantastically. Okay, so thank you very much. So this completes to end of our communication basics. So wait for my network basic lectures. So very shortly we'll be starting about the networking basics. So please, the students who are watching first time my lecture, please watch all these lectures from the episode 1 to 15th. So you will have a very sound, good understanding as far as the communication basics are concerned. So with this particular knowledge, you will be able to easily understand what is the network basics, and advanced networking will be very easy for you people. Okay, if you are not subscribed, please subscribe to my channel. So further, you'll be getting the best of the videos you can watch and learn, okay, in a nice way. Thank you very much, and bye.